This is the video that goes with example 13. It's our second example of using moles and equations together. And in this case, the example is a student was dissolving sodium and calcium in several beakers of sulfuric acid. It's quite dangerous, I wouldn't recommend you do that in the lab, but they were doing it at 25 degrees and 100 kilopascals. The first question is, what volume of hydrogen gas will be produced if 5 grams of sodium reacted? And the second question is, if the student needed to produce 55 mils of hydrogen gas, what mass of calcium would need to be reacted? Now, look back at our spider diagrams. We can follow these questions through the path of the spider diagram. In all these questions, we're told something about species 1. We've got to find something about chemical species 2. So in part A, we've been given the mass of sodium. We can convert that mass of sodium to a number of moles of sodium using this equation. So now we know the moles of sodium. We need to write down the balanced chemical equation for the reaction between sodium and sulfuric acid in order to find, using the mole ratio, the moles of species 2, which in this case is the hydrogen gas. And once we know the moles of hydrogen gas, we can use this equation here to find the volume of hydrogen. And that's the path through that particular question. For part B, we've got to find the path through part B. In this case, we've been told what volume of hydrogen gas needs to be produced. We can convert that to a number of moles of hydrogen gas needs to be produced using this equation. Now we know the moles of hydrogen gas. We can convert that by the mole ratio, once we've written the balanced chemical equation, to the moles of calcium that needs to dissolve. Once we know the moles of calcium needs to dissolve, we can use this equation here to find the mass of calcium we need to dissolve. So let's see how we do that. First of all, we always write down our data for the first question. See if you can write the data down for this question. If you want to pause it, you're more than welcome. And what you should have got is that there are 5 grams of sodium. The molar volume is 24.79 based on the temperature and pressure, and we're trying to find the volume of hydrogen. The next thing chemists do, once they've got their data down, they write their balanced chemical equation for the reaction. You need to be able to do this yourself, so please pause the video and have a go at this before you check your answer. Hopefully you've got 2 sodiums plus 1 sulfuric acid turns to sodium sulfate plus hydrogen gas. And the next thing we need to do is we need to find the volume of hydrogen. And we know the equation for that is number of moles times molar volume. We know the molar volume, so once we find the moles of hydrogen, we can solve this problem, and we can find the moles of hydrogen via the mole ratio using the moles of species 1, which we can calculate. In this case, species 1 is sodium, because we've been told the mass of sodium. Number of moles equals mass of molar mass, which in this case will be 5 divided by 22.99, because that's the molar mass of sodium. I'm going to get this number here, 0.2175 moles. Now I'm going to store that in my calculator because I keep that in my memory in my calculator. I'd like you to do that as well because you need to start practicing using the memories in your calculator. So I'll store that as A in my memory. The next thing is to use the ratio. Now, looking at the ratio here, moles of sodium divided by 2 equals moles of hydrogen divided by 1, which we've got written down here, or just the moles of hydrogen, the thing we're trying to find, is just the moles of sodium divided by 2. So what's the moles of hydrogen? It's just the moles of sodium, which we've got stored in A in our calculator, divided by 2, which equals this number here, 0.10875 moles. I'm going to practice using my memory of my calculator. I'm going to store this in memory B this time. I'm just stored in memory B. Last step here is just to substitute. We're going to actually figure out the volume of hydrogen now. We already said the volume is equal to number of moles times molar volume, which is this number I've stored as B in my calculator, times by 24.79. That gives us 2.696 litres of hydrogen gas produced. Remember, litres is our units in chemistry, particularly when we're using molar volumes. The last thing is significant figures. See if you can figure out what the answer should be to the right number of significant figures. Just pause it and have a go, please. Okay, so I checked the significant figures. It looks like there's 1 significant figure in this number here, and therefore I should have 3 litres as my final answer. For part B, I should say, not part A, for part B, the data we've been given information about the volume, molar volume, and mass. We know we've got 55 mils of hydrogen gas need to be produced. We can't use mils in our calculations. We need to replace that little milli with its numerical component. Milli stands for 10 to the minus 3, so that's really 55 by 10 to the minus 3, which is 0.055 litres. The molar volume again is 24.79 litres based on the temperature and pressure, and we're trying to find the mass of calcium. The next thing we do as chemists is write the chemical equation down, so please pause the video and see if you can get the chemical equation right for this reaction. You should have got calcium plus sulfuric acid goes to calcium sulfate plus hydrogen. Now we've got that, we need to find the mass of calcium. We know that's number of moles times molar mass. We know the molar mass of calcium. All we've got to do is find the number of moles of calcium, and we can solve this problem. We can find the moles of calcium via the mole ratio, particularly because we can calculate the moles of hydrogen gas. How are we going to do that? Moles equals volume divided by molar volume. We already know the volume of hydrogen gas is 0.055 litres. Divide that by, that should say 24.79, I apologise, not 22.79. Divide that by 24.79, sorry, 20, here we go. That should give us 2.2 by 10 to the minus 3 moles of hydrogen. I'm going to store that as A in my calculator memory. I'm going to rewrite that old A, I don't need that anymore, just to practice using my calculator's memory some more. The ratio, looking at our equation here, calcium divided by 1 equals the moles of hydrogen divided by 1, or just the moles of calcium equals the moles of hydrogen, which is nice and easy. So therefore the moles of calcium is just the same as hydrogen, 2.2 by 10 to the minus 3 moles. Last thing here, I can do my substitution to figure out the answer. Mass of calcium is number of moles times molar mass, which is that 2.2 by 10 to the minus 3, which is stored in my calculator, times by 40.8, which is the molar mass of calcium, gives me the answer of 0.8892 grams, but I've got to check significant figures. Looking at my data here, that looks like two significant figures to me, therefore the final answer is 0.089 grams, two significant figures.